Hi viewers, we are going to see the Faraday's law of electromagnetic induction. Why we are going to learn the Faraday's law of electromagnetic induction means it explains the Faraday's laws of electromagnetic induction explains how electricity is produced from magnetism. Okay, how electricity is produced from magnetism. Okay, Faraday's law of electromagnetic induction explains how electricity is produced from magnetism. That's why we are going to see the Faraday's laws. There are two laws. Okay, there are two Faraday's laws. First law. Whenever a conductor is placed, whenever a conductor is placed in a time varying flux. Okay, whenever a conductor is placed in a time varying flux, an EMF is induced. An EMF is induced in a conductor. Okay, this is the statement of the Faraday's first law. Okay, whenever a conductor is placed in a time varying flux, an EMF is induced in a conductor. Time varying flux. Okay, time varying flux means flux is varying with respect to time. Okay, here flux is varying with respect to time. Whenever a conductor is placed in it, okay, whenever a conductor is placed in the flux that is varying with respect to time, and EMF is induced in a conductor. This is the first law of Faraday's electromagnetic induction. Second law. Let us see second law. Okay, the magnitude of EMF induced. Okay, the magnitude of EMF induced is directly proportional to the rate of change of magnetic flux. Okay, this is the second law. The magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. Means first law explains how EMF is induced in a conductor, and the Faraday's second law explains the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. That equals E magnitude. Magnitude E is equal to d phi by dt. Okay, actually we write this formula Faraday's second law. E is equal to minus d phi by dt. This negative sign represents the direction of the induced EMF. This negative sign represents the direction of induced EMF. Okay, this negative sign represents the direction of induced EMF. Faraday's laws, both laws states that first law, how the EMF is induced, and second law states what is the magnitude of EMF induced. Okay, and the direction of EMF induced is represented with the negative sign, and how the negative sign is identified means how the negative sign is identified. First we have to learn how the negative sign is identified. Negative sign is identified by using Lenz's law. Okay? By using Lenz's law. The magnitude E is equal to d phi by dt. It is given by Faraday's law. Magnitude. Magnitude is given by Faraday's law, and E is equal to minus d phi by dt. This negative sign is given by Lenz's law. Okay? Negative sign is given by Lenz's law. According to Lenz's law, this negative sign represents that EMF induced opposes the cause that is produced. Okay? With respect to the flux, that is the change in the flux is the cause to produce the EMF. So this is the cause and EMF induced is the effect. By the Lenz's law, effect opposes the cause, that is represented with the negative sign. Okay, this is the Lenz's law. And the induced EMF induced direction can be identified by using Fleming's right hand rule. Fleming's right hand rule, or it can also be known as right hand thumb rule. Right hand thumb rule.